I want to talk about just a little, just a few minutes, about a concept called effect size. If you look at, again, Green Salcombe, the softcover book, there's a formula at the top of page 165. It starts at the bottom of page 164, but the one I want to get to is the formula at the top of 165. I'll tell you what this is. The formula is D equals T over the square root of N. And that's called Cohen's D. C-O-E-N, Cohen, or somebody just say D. This is a measure of effect size. There are different formulas for effect size depending on what kind of procedure we're looking at. This is the formula that we use for a single sample t-test. It's just simply D over the square root of N. In our case, what was our t-value? No, that was our test value. Our t-value, 2.457. And divided by the square root of N, which it was, I believe, 30. If I slide the things on the rack of my abacus back and forth a little bit, I find that that calculates to 2.457. Oops. Can't punch the right buttons. I get that to be approximately about 0.45. 0.45. Now, here's what effect size means, and here's what effect size means. Effect size is essentially a small, medium, or large classification. It's kind of like the size of French fries you get. You want small, medium, or large. And our kind of rule of thumb are 0.2, 0.5, and 0.8. Small, medium, large effect size. Okay, that's what effect size means. Here's what effect size means. I can't find any better words than the words of a former student in this class, and said that, oh, it's kind of like how significant is the significance. I kind of like that. Okay, you got a significant difference. Big deal. Small, medium, or large effect size. In this case, it doesn't quite reach the medium, and I'm a little uncomfortable, quite honestly, that they pin these down to such specific numbers, because the answer is what is small, medium, large. The answer is it depends. But we're going to go with what they've got. So we would say something like, this is a small to medium effect size. So we just simply classify it small, medium, or large, or somewhere between two of them. Not quite medium, but it's close enough to say it's getting up there. So effect size is a relatively new concept. Now you have in the SPSS for a t-test, it will not do this for you. I don't know why. Is it really that difficult to divide two numbers together? Heck, we couldn't even divide by 2 a minute ago to get a one-tailed p-value. So we're sure not going to do this, although we will find out in more complex calculations, it'll calculate a measure of effect size later. There are a couple ways, things that are called, this is the D, or the Cohen's D. We're going to see something a little later called eta squared. That's also, it's a Greek letter, yeah, ETA. And I'll show you what that looks like. You got a grandmother named that too? Okay, okay. So again, just an introduction, a 5-minute introduction to effect size is that there's the way to calculate it for, again, this is for a single sample t-test. Other procedures have different ways they calculate it. For example, in this case, I have only one sample, that I just have one in. Sometimes we'll have more than one sample, so we'll have more than one in. This has only room for only one. So just as an introduction, single sample t-test, t divided by the square root of n, and we interpret that as small, medium, or large. The larger the effect size is, the more significant the significance is. And generally, if you don't get significance, if you get something that's non-significant, you're probably going to get a small effect size, which you would expect. The more significant something is, the larger the effect size is likely to be.